Hey, security pros, welcome back to my masterclass on using AI agents in cybersecurity. So, if you remember back to last lesson, you'll remember we built our first cybersecurity AI agent that could plug into our EDR and summarize a few alerts for us, and we could even interact with it and talk about those alerts. But in a real world scenario, that's not actually going to help us that much. So today we're going to tweak that agent into something you can actually implement in your place of business for a huge value add. We're going to make a true alert triage agent in n8n. I'm really excited for this one, guys. This is Ben from Atlantium AI, and let's get started. Okay, here's a simplified version of our architecture diagram. Just remember in our Wazuh stack, we've got our dashboard container, we've got our manager container, and our indexer container. Additionally, in the same network, we've got our n8n container. And what's really happening here is n8n is querying the indexer, which is where our security data lives, within this network, pulling back some alerts to analyze and sending them to Gemini out here to do the analysis on, do the summaries on, which then is coming back. And if you remember from our last lesson, we're only pulling like 10 alerts back. And 10 alerts, it's not too much data. You know, we've got alert 1, 2, 3, blah, 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 all the way down to 10. And I mean, how many tokens are we talking about here? Probably less than 500 tokens that we're sending to Gemini. And it's able to take these alerts, digest them really well, and give us a great summary. But the question is, does this scale? So what happens when we pull back 100 alerts? Well, now we're probably talking maybe in the thousands of tokens. What if we had just run Atomic Red Team and we've actually got 400 alerts in our indexer that we need to analyze? Okay, now we're talking about maybe 8,000 tokens, and this is just on one machine that we're going to try to send to Gemini. Well, that starts to become a problem because of three principles. We have the context dilution principle. And what does this mean? This means that the more irrelevant or repetitive information in the prompt, the less effectively the model focuses on the key signal. You better believe that when we dial this up to 100 or 400 different alerts, that there are going to be tons of repetition in here, especially if we're just doing alert triaging. We're really going to start to run into the limits of even Gemini. Gemini can take more tokens than most models. However, we're still going to run into the context dilution principle, and it's going to kind of hurt our output because it can only handle so much. Okay, number two, the second principle is information compression loss. So info compression loss. So what is information compression loss? Well, LLMs internally compress long context to fit in their working memory, which leads to loss summarization. So that means that the more data we're going to throw at it, the more likely it is to forget some of that data or just to not use it. We can't just throw an unlimited amount of data at these models and have it actually do a good job with it. And number three, token budgetary inefficiency. Token budgetary inefficiency. So what's token budget inefficiency? So every token costs attention. And so redundant tokens reduce reasoning depth per token. Okay, so what does that mean? Well, if we've got tons and tons of repetitive information in here, i.e. from like a bunch of different alerts, well, it's going to start to decrease the amount of reasoning that it can use on some of those other tokens as well. So what does this mean? It means that this current architecture we have with our agent is not going to scale well, especially if we want to summarize all of the alerts within our EDR. So with that being said, what are we going to do? Well, in the indexer, right now we are just using get alerts. But there is another function we can use with OpenSearch called ag. Why should we get every alert when we could just say, hey, there's 30 of these alerts on this machine? Now, do we lose some context? Yes, a little bit. But for the purposes of what we're doing, and especially using like LLMs, which can be limited on their memory, this is going to give us much better results than if we just pull all the alerts, throw them at the LLM and say, okay, LLM, go. That's just not going to work. So this is our goal, and let's get started. Okay, let's get started with some hands-on keyboard here. The first thing we're going to do, I'm here in the lab setup Git repository. Go ahead and do a git pull because I've updated some of this since our last lesson. Now it's already up to date. Yours might not be, but just a reminder, if you need to get this repo, it's just at github.com/atlantium-AI, and it's Wazuh n8n lab setup. Okay, so now let's move over to Postman, and we're going to import the most recent collections. Let's go to Files. Go ahead and just re-import this Wazuh Postman collection JSON. Now it's going to say it's already exists. What you'd like to do, go ahead and just replace it. Okay. And then open up the indexer APIs, and let's go to this new post request that is to count the alerts. So if we go to the body here, all it's doing is it's counting the alerts given two filters, a timestamp, so this is the last 24 hours, and the rule levels. So right now we're going between 1 and 10. And let's go ahead and send that just to see how many alerts we're dealing with right now. Okay, so we've got 249 alerts. All right, well, let's go into the search alerts. This is the version that we used last time. Let's go ahead and go into that body. And you can see last time we were pulling 10, maybe 20 alerts, but right now we've got over 200 we need to deal with. So let's go ahead and pull 100 alerts. And let's see what that ends up looking like. All right, so how many alerts? We just pulled back 100 alerts. Now let's go ahead and take a look and see how many lines we're talking about here. Okay, so 100 alerts, and we've got over 2,000 lines of code. So you can pretty much guess we're at least 2,000 tokens for the AI. Now, keep in mind, for a single prompt, the limit on Gemini 2.5 Flash, what we're using, I think it's somewhere around 8 to 10,000 tokens. We're probably pushing that limit right now, and we haven't even gone through all of our alerts. And now we're getting into some of the issues that we were talking about earlier in the architecture section about context dilution. Essentially, the models are going to struggle when we send them this much information. I mean, a lot of times we want to just send the model everything and say, okay, model, deal with it. But we have to realize, especially when we're talking about security data, like it's going to have limits. We're really going to need to try to optimize some of this. So if we were to do this the poor way, we could add this search alerts v2 and we could paginate. So we could have the model go through and pull a search, pull the next page and the next page and the next page, maybe do some processing on it, and eventually it's going to give us back something useful. So let's go ahead and see what that might look like. So here I'm on search alerts v2. The body is going to look pretty similar. I've got 100 alerts, and this time we can search by any given time and by any given rule level. Okay, now if we scroll all the way down to the bottom, let's see, what rule level was I on? Okay, 4 to 7. Let's move this from 0 to 10. Okay, so we're going to have to go all the way here to the bottom, and we've got two parameters, which is sort and then this ID. I think this is a timestamp, and then that's an ID. So we're going to go ahead and copy this, and then we're going to go to our search after. And in our body, we're going to go down here to search after, and we're going to just replace these two values. Let's see if I can give us a little bit more room here. Go ahead and paste that, go back, and we need to get this ID as well. Okay, and then we would send this search after we sent the first one, or have our AI agent do it. Okay, so now it gave us the next page of the results. So it gave us the next, I believe, 100 results. And it's essentially, we would just keep doing this until we didn't get any results back. But that is going to be a lot. Actually, you know what? I need to change this rule level again. We're going to go 0 to 10. Okay, so now we've got a lot more results. There's another 2,200 lines or something like that. Again, this is really too much for an agent to handle all of the data on all of these alerts, especially at this point. We're just trying to triage the alerts. We're not necessarily trying to dive into each one. So that's when we come to our endpoint aggregation search. Okay, so what is an ag search? Some of you, if you're familiar with SQL, this is essentially OpenSearch's way to do a group by. And you can do a group by several things. And so we're going to take all of that redundant data and we're just going to summarize it for the AI agent. And let's go ahead and see how this one will perform. First, let's walk through the body. Okay, so what have we got going on here? So we've got our filters. We've got a range timestamp now minus 24, less than now. So this is so our agent can pick not just the last 24 hours, but ideally we should have it be able to pick any day in any time period that it wants to summarize. Here we've got the rule level. Again, this is our low, medium, high critical alerts. Now I did add also this must not element here. And so what it is, so it should not exist data vulnerability.cve. So Wazuh has been doing some interesting things lately where they're actually putting in, if you've got like a CVE on the same machine where your agent is, it's like pushing that up as an alert, like it leads to an overwhelming number of low alerts. We're talking in the thousands. And so this is going to filter out all of those CVE alerts, and it's going to just kind of give us the log alerts from logins, from audit D, etc. And now let's scroll down to the AGs. This is where the magic happens. So the first thing we're going to do is we're going to aggregate by endpoint. So right now we've only got one agent, so it's just going to show us that one, and it also shows us the Wazuh manager. For some reason, it generates a low alert whenever that starts. But in general, we're just going to be focusing on the Ubuntu agent. However, if we had multiple agents like Windows machines and maybe some other servers that we were using, it's going to give us all of the alerts broken down by those endpoints. The next one we're going to do is by finding title. So in this case, instead of if we've got 30 alerts for a failed login attempt on one machine, instead of giving us each of one of those 30 alerts, this is just going to say failed login attempt. We've counted 30 of those. Now down here, I've added a few more aggregates. This is just to give the agent a little bit more context for some of the random alerts that come up. Some of the data that comes up is like which command was used to generate the alert. If there is nefarious things going on your machine, that data.command is going to be really useful for the agent. And then we've also got by destination user. So if someone's trying to log in, this is going to give us, okay, what user are they trying to log in as? And maybe that's where we need to start taking some action by having that user change their password or things of that nature. And then by package, this is when if something is being installed on the machine. So this is the Debian D package. If they're trying to install some malware, let's see what that actual malware is. Now, when we take this a step further down the road, we can even grab the hashes of the files that are being installed. And then we can push that up to VirusTotal to see, hey, is this actually a malicious package? I don't know. And our agent can do that for us. So that's walking through this aggregate search. Let's go ahead and see what it looks like. Now, I do want to point out one thing. If you haven't run Atomic Red Team in a while, those alerts may have fallen off your dashboard. So if you need to, go back to the old lesson, find those commands. Again, they're on my website at atlantiumai.io, and go ahead and run those again so you can generate some good traffic. Okay, so let's run this query and see what happens. Get the response window up here. Okay. So let's take a look at what this is actually going to look like for us. So notice we've got our aggregations by endpoint, and we've got our Ubuntu local agent right here. And then underneath that, we've got audit D SEL Linux permissions check, 260. And then you can see we've got our sub ags by destination user, by package, and by command, but none of those apply to that particular alert, so they're just all going to be 0. Now I will say this isn't necessarily ideal to have a bunch of empty data here. And in fact, I think in a future video, when we optimize this agent even more, we can do some data purification or sanitization where we go through and find any empty filter or ag like this, and we'll just remove it. And that will give the LLM even less data that it has to worry about. But let's just go ahead and see. PAM login session opened from root, 33 of those. Login session closed, root, 31 of those. That could be interesting. Successful sudo to root executed. And there we've got by destination user, again, root. So this is looking pretty good. We've got the findings, some extra data, and we just get a count of how many times did this finding happen on this particular agent. I do want to point out some of this too. So by command, this particular finding is successful sudo to root executed. I notice we've got lots of commands here, and a lot of these, temp evil binary are pretty nefarious. And again, this is from running Atomic Red Team. So the agent's going to be able to dig through this pretty well, I think. Let's go ahead and add this to our n8n agent. And when I say add, we're actually going to just clone the old agent and make a new one. So let's go over here to n8n. And remember, to get to n8n, it's just HTTP. Don't do HTTPS for the lab. In production, do HTTPS. And then the port is going to be 5678. Okay, so I'm going to jump out here. This is what we did last time. Also, always remember to save your agent. I've got bit by that a couple times where I closed out without saving, and it just loses everything. n8n, if you're watching this, I would really love an autosave feature. Okay, so let's go ahead and just duplicate this one. So this is, actually, let's rename this first one to first n8n, or let's just say first agent. Okay. Now let's go ahead and duplicate it. And we're going to call this one, I mean, you can call it whatever you want, but this is going to be our alert triage agent. Okay, so the only thing we're really going to change here, at least for now, is this HTTP request. So let's go ahead and go into this HTTP request. This should definitely be a post. Okay, so it is the same endpoint, which is Wazuh alerts 4.x-star /search. And remember, we've got our basic auth. It should have copied over your basic auth from the last agent. And then we are going to do the raw alert. I'm going to back this off just a little bit. Okay. And that might be a little much. Okay. So let's go ahead. I love this little pop down thing here because it gives you an editor that's a lot easier to use. And it even shows you like, this is what your expression is, and this is what the result is going to be. So let's go back to Postman. And let's just go ahead and grab this body here from the endpoint ag search. Copy. Okay. All right, so now we need to actually point the agent to what it can define in this workflow. So I'm thinking right now we're going to let it define the greater than and the less than parameters. We're also going to let it define the rule levels as well. And the rest of this is going to stay pretty standard. So let's go ahead and do that now. So here is going to be, remember to let AI specify certain parameters. We're going to do the double curly braces. And then it's going to be $ from AI. And the key is just any arbitrary key. So this is going to be GTE timestamp. And what this is going to be just a quick description. So this is the time stamp that to search after use now minus. Okay, so we're going to say use relative timestamps if possible, and we'll even give it an example. Example now minus 24 hours. Okay, and then we need to do the data type, which this is going to be a string, and then we need to give it a default value. And let's go ahead and just do now minus 24 hours. Okay, now let's also do the same thing for the less than time. Let's go ahead. Okay, now we also want to let it search on the rule level. So let's go ahead and do it again. From AI, this key is going to be rule, let's see, greater than rule level. Description is the, okay, let's just copy this. Here. And let's just go ahead and we'll just do 15 so that it gets pretty much all of the alerts. Okay, now this should be it for the aggregation. So let's go ahead and just look at our agent system message. But first we're going to save so we don't get bit by that. Okay, let's look at our system message. Let's go ahead and do the pop out again. Okay, you're a helpful assistant. You are an AI security analyst. Your job is to query alerts from Wazuh Indexer and summarize the results for the user. So we're actually going to change this. Your job is to not just query alerts and summarize. It's going to be and triage the alerts for the user. Alert severity mappings. This is good when summarizing results. Okay, so here's where we might need to change this a little bit. Let's go ahead and we're going to pull up our good friend ChatGPT to help us write a system prompt. Okay, let's just ask it, can you generate? Yeah, let's just try that. Okay, so you can see ChatGPT, this is like we could use this. It's a little bit long. And again, like we're going to start to run into some of these length problems with the LLM. So let's go ahead and see if it can shorten that up again. So this is good, but I want it to be shorter and less specific, because we want to let the LLM actually use some of its own intelligence. Now, I will say, if you find yourself in your company where you've got some unique use cases, feel free to like put those unique use cases into the system prompt. Think of it like you're actually training your cybersecurity analyst for your company when you do the system prompt. this looks good enough for now. Let's go ahead and try it. Back to n8n. Actually, this is the one we're on here. All right, let's give it a shot, see what happens. Once again, don't forget to save. Okay, let's see what we can do here. Okay, so let's try this. Hey, can you triage and summarize my low alerts for me? Oh, didn't like it. Let's see what's going on here. Bad request. Please check your parameters. Okay, sorry about that, guys. I had to do a little bit of troubleshooting. So one thing we need to make sure of is in your HTTP request, in the body, let's see, when we specify the timestamp, the relative time, we actually need to wrap this whole thing in quotations. So I was forgetting these little quotations right here. Make sure you have those, otherwise it won't work. Okay, and that should be a good start for us. Let's go ahead. I'm going to reset this chat session. I'm going to say, hey, can you triage all of my low alerts from the last 24 hours? What should I focus on? And what is most likely noise? Hey, let's see how she does. Okay, here's a triage of your low severity alerts from the last 24 hours. Most important things to focus on. It says there were some successful sudo to root executed findings. While these were initially classified as low, the commands executed in some of these instances are highly suspicious. That's good, because some of them have evil.exe or something in them and could indicate malicious activity or a penetration test. And it gives us some of these suspicious commands. I think this is great. These commands suggest attempts to delete potentially malicious binaries, blah, blah, blah. Okay, so you should immediately investigate. And then we've got most likely noise, audit DSEL permissions check, very frequent audit event, a high volume is expected. PAM login sessions, a few instances within the 24 hours are often routine, especially if administrators are actively managing the system. I might even help the agent a little bit on this one because there were 33 occurrences of root on Ubuntu local. We might want to give it a threshold on like, okay, if there's more than 15 instances of sudo executed, maybe at that point we want to start escalating it. And the beautiful thing about this is you can just put it in the system prompt and that becomes your policy and it's coded right into your AI agent. So I hope you guys enjoy this video. I hope you found it useful. And just remember, if you have any issues, reach out to me in the comments. If you'd like to employ our services to get this up and running within your company, please feel free to reach out to me. Just go to my website through the contact form. I try to be very responsive on that as well. Well, thank you guys. I hope you can like and subscribe, support the channel, and I will see you in the next one.